Hi, I'm Cliff Hall, and today I'm going to be talking about SineWave, a 3D visualization system that allows artists and labels to create interesting videos for their music and upload them to YouTube and other video services. Once the user has signed in with either a social media login or an email address and password, the system will be divided into three main areas. For the artist and label who are looking to create music videos, the projects and assets areas are key. Projects allow them to create the videos, assets allow them to customize the content of those videos. And the plugins area is specifically for developers. Developers will extend the system by creating these plugins which do things in the 3D world, create objects or move things around, reacting to the sound or not, as need be. And the artists will be able to take these plugins and create their videos. Once the system has evolved and is ready for prime time, developers will be able to get a revenue share from the plugins. When a artist uses the plugin, the developer will get a cut of that income. So for now, I'd like to speak directly to developers. Developers will extend the system with all of the awesomeness that musicians and labels will be able to use to create their videos. You can think of SineWave as something akin to JS Fiddle for 3D. You, as a developer, you need to know JavaScript, Three.js, and WebGL in general. So creating a plugin is as easy as giving it a name. You come in here. If you're going to publish this, then you want to give it a description, explain how all of the settings work, and how to actually integrate it into your project. And settings, your plugin doesn't need to have settings, but generally that's the way that your users will configure your plugin. Settings are always inside of groups, so there will always be at least one group if there are any settings, and we're trying to name those appropriately. Like, let's say we have some assets, and let's say we're going to have a 3D model, and settings can be assets, booleans, colors, enums, floats, integers, modulators, more on that later, and strings. In this case, we're going to say it's an asset. What type of an asset? In this case, it's going to be a 3D model. And when you create a setting of any type, you set a sane default for that. And that way the user makes changes, they can always reset to the sane values and configure again if they need to. So in this case, we'll provide a default model. You might upload a skull. The user might later upload their own model of a horse and change the value of the setting to that. But this gives them a way to see what your plugin is doing. So next comes code. And you'll notice we've got three functions defined here. That's all that's required of your plugin. A setup function is called when the visualizer is preparing to render. It loads all of the audio, it sets up all of the plugins and gets everything ready before rendering the first frame. This is where you create any objects, functions you want to call later during render, that sort of thing. And then render is a function that gets called for every frame, and you can move your objects around, change their size, whatever it is your plugin needs to do. And then there's a destroy function. If you've done everything right, you shouldn't really need to use the destroy function. This is necessary so that if you look at examples on the web, they rarely clean up after themselves because it's just a page, it creates some stuff, and then you close the tab and you're done. But in this case, the user will be going in and out of the visualizer, looking at different projects and so forth, and we don't want the memory to be increasing because we didn't get rid of some materials, we didn't get rid of some geometry, something like that. So this is one of the places where SineWave helps with the heavy lifting. You create a material, you register it, that lets you get the material later by name, and or geometry, and it also helps the system go through and dispose of all of those materials and geometries in the end. So essentially that's it for what a plugin entails. Next, we'll take a look at how this looks from the standpoint of taking a 3JS example and converting it to a plugin for SineWave. Now let's take a little deeper look at plugins by converting a existing 3JS example to a plugin for SineWave. We'll go to the 3JS examples, and here is an interesting example using geometry. The colors on there, of course, are using mesh normal material, which gives a color based on the direction of the normal. So you get these whirling tentacles. It's basically a hierarchy of geometries, a bunch of boxes extending from one central box, and each box is parented to the one above it, and essentially a rotational value is iteratively added to each of those boxes. So the parent of any box gives a certain amount of rotation to the box under it and all of its children, but then that first child is given the same rotation, and that cascades down, and so you get this crazy whipping tentacle effect. So let's take a look at the source code for that. Let's see what it does. Of course, it sets up a mouse move effect, and we're not going to really need that in our visualizer because the user won't really be interacting with it in that way. We'll set up settings that control how it moves. It can be modulated by audio, or it can just kind of do its own thing. We'll see how that goes. An element is created into which we're going to put the renderer's canvas, and a camera is created, a 3D scene is created, and a scene background is created. These are things, the scene and the rendering element is part of what SineWave does for you. And we create some box geometry. We only need the one box, and we create a mesh normal material, and we put that in we give it a position, and we add it to the scene. And then we go through and add a couple of hundred boxes in each direction. You can see we're going in position X by 100. We're going into position X minus 100, position Y minus 100, position Y 100, Z plus and minus 100, and so forth. So that's how we create this great big set of legs to begin with. Then we set up a renderer, and you don't need to do that in SineWave. That's taken care of. Create stats, you don't need to do that. You don't need to do window resize listener, that's all handled. And set up the animation loop, you don't need to do that, that's handled. And then we get down to the render function, which is called for every frame, and we can see that we do a little bit of math there to create some rotation values, and we do some camera positioning based on the mouse, but we're not going to do that. And we traverse from the root object, we traverse down and we apply that rotation to all of the elements. And again, that cascades since all of those elements are parented, and then we get the whipping tentacle effect. And then we call render on the scene. Again, that's something that you don't need to do in your plugin. That's handled by SineWave. So let's see how all of this breaks down into a plugin in SineWave. So we have, first we want to be able to position this thing somewhere in space. And so we're going to set up some settings. The group will be called position, and we'll have X, Y, and Z positions with sane values, minimum and maximum, and step values. You can see, you can go in there and you can edit these values if you like. And the code, you'll notice we do this context refer, the setup, all of our functions setup, render, and destroy are passed an object called context. And what that is, it's not the WebGL context that you might think. It's a context that is carrying all of the information that the plugin needs to know to do its job. Remember, these plugins can all be, multiple plugins can be running side by side in the same scene. So a plugin, its context is meant to give it access to its objects so that it can't mess with the other ones in the scene, and give it access to the scene, allow it to register its materials and geometry and so forth, and provide some memory, which can be later. You'll see we're saying context.memory.startTime, date.now. That's beginning time of the whole thing. Later, for every frame that gets rendered, we can refer to that variable, and we can also define functions on context memory, and we'll create a locate function, and that is going to take the root object, is going to be passed into that function, and it's going to get from the plugin setting group called position. Remember, we created a group called position, and it had X pose, Y pose, and Z pose settings. So we're going to get that setting group, and then we're going to set the X, Y, and Z position based on the values of those settings. And the reason that we're setting this in a function is that the user, when they are actually using this plugin, will be able to actually tweak these settings in real time. So we want to be able to find that where the position is and place the thing on a frame-by-frame basis. Now we're going to create that box geometry and we're going to register it, giving it a name. That'll allow us to reach it later. And we're going to create the mesh normal material that we're going to put on all of those boxes. We're going to register that and give it a name. And then we're going to create that root object, that box in the middle of all the tentacles by giving it the geometry and the material. And we create that in the same way that we would, we create all of this geometry, the materials, the meshes, in the same way that we would normally do with Three.js. And then we're going to call that locate function that we just defined up here. We're going to call that to begin with to position the thing. And we're going to also store a reference to that root object in our memory. In our context memory. And finally we're going to add that to the scene. Now notice we're doing context.add to scene. We don't actually get a handle to the scene itself here. Again, we don't want plugins messing with each other, possibly doing things like that. And also when we add objects to the scene, SineWave remembers them and can later remove them from the scene and so forth. And here's that same code that we saw going through and creating all the legs of the tentacle object, and that's all just the same as it was in the demo. And now we'll look at the render function. In the render function, okay, we're going to define a speed and we're going to multiply that by the current time, and we're going to do the math. This is basically what was going on in the demo, using the sine waves to determine rotation values. And we're going to get a handle to that root object. Now remember, this is not one big JavaScript file. These are discrete functions that are called when they need to be called, and they're passed the context so that they can get back to what they need. So we'll pull that root object out of memory, and we'll do a locate on it, position it in space in case the user has changed the settings. And then we'll traverse the object and we'll apply the rotation to all of its children, just like the demo did. And we don't need to do anything in destroy because we have registered both the material and the geometry, and so SineWave will clean those up for us when we're done. And so you can see that's all we need, and the plugin is ready to go. So now let's go over and have a look at what that looks like. And this project has multiple worlds, and of course during the course of a song we will probably want to change up what's going on. We don't want the same plugin or set of plugins just basically going through the motions for the entire length of the thing. So we create worlds. Each world has its own scene, its own camera and lighting, its own set of plugins and settings and so forth, and the user is able to see all of those worlds at any time. They can go between them, and in the end when they create their final video they will be able to say, okay, show me this world at this time, now transition to this world, now let's see this world, and so they'll have lots of different things going on. So here we have 3 worlds, and in this case we're demonstrating the use of backdrops, a image for a backdrop, a static color for a backdrop, or a cube map environment for a backdrop. And we have some different plugins going on in there. We can see that there's a separate plugin being used to provide the scene image or color or cube. We've got this camera transform, which is going to be in charge of getting the camera and moving it around. And we've got something called heart. That's an object that's going to react to the audio. And we've got the tentacles, which we've seen in the example, what they do. So we're going to just go ahead and visualize. And during this time, it's going to load all of the textures and so forth, and then set them up and get going. At this point, it's already called setup on all of the plugins, and now it's calling render on each one of them. So that's essentially how plugins relate to the final product. And you can see it was fairly easy to convert a existing Three.js example to a plugin. There's a lot less code involved in the final product, and you can drop it into alongside a bunch of other stuff and get some interesting things going on. So that's it for now. I just wanted to give developers a view of where the system is, how easy it is to go in and play around and create something interesting and unique, which musicians can then take and put into their videos. Again, when the system is ready for prime time and we're charging customers for the videos that they create and upload to YouTube, we will be offering revenue share to plugin developers. If a customer uses your plugin in their video, you will get a cut of that revenue. So that's nice, but even outside of that, it's like JS Fiddle. It's a quick way to be able to get some 3D stuff up and running. It's a good way to learn Three.js. It's a good way to get your hands onto the important parts of Three.js without having to worry about the whole setting up the rendering and all of that stuff. So again, if you're interested in coming into this early adoption from a developer standpoint, contact me at the email address at the end of this video, and we'll let you start playing around with it. Tell us what's good, what's bad, what's ugly, what we need to do to improve it, what we need to do to get it ready for prime time. Thanks.